I think we're doing very well with time, and this means that we have plenty of time for questions and comments from the audience. Guess we can start on this side.
People are tired.
We have a microphone.
Thanks. Sorry that took so long. John, I'm here.
I can see you, Drummond. It's very difficult to miss you.
I want to. Thanks. I wanted to say how interested I was in your paper. What you didn't say was that there was a character called Diederik Stapel, whom you'll know all about, and I don't know if you were part of the really remarkable report issued by 3 Dutch universities in 2012, the Stapel report, and I think your university, Tilburg and Amsterdam and another were involved. It's a very readable, very, very much worth everybody's look at, and it includes the efforts the statisticians made to put things right. I'd strongly advise you to read it, and congratulations.
Thank you. I agree, and not because I work at Tilburg University, where Diederik Stapel, the fraudster in this case, was the dean, but because it has this transparency. So the investigation was very, it covered the entire oeuvre of Diederik Stapel and an assessment of the cultural, social environment in which he operated. Actually really, just like in any air disaster investigation, in an effort to improve it. Yeah, thank you.
Steve?
Hi, this is a question for Jelte. And one thing that's interesting about the way statistics are used in biomedicine and in science is how dramatically different the uses and interpretations and dominant sort of ideology and methodology is in many, many subdisciplines. You'll look in economics, you'll look in astronomy, you'll look in biomedicine. You'll see very different emphasis on effect sizes and significance and those things, even though, of course, significance always has some degree of impact. But I think psychology, I don't want to say it's unique, but it seems to be on the extreme end of the worship of the bright 0.05 line and the declaration of significance versus non, and that being so powerfully determinate in terms of what's viewed as a true hypothesis versus not. And it seems that a lot of the problems you're describing in the psychology literature are manifestations of this very extreme worship of null hypothesis significance testing. That if it's on one side of 0.05, we regard it one way. If it's on the other side, we regard it differently. When in fact, if it's 0.07 or 0.04 or 0.01, I don't have almost any different reaction. What's much more important is the prior probability of the hypothesis. Those are all weak evidence. So how much of this is solved through all these technologies to adjust p-values versus changing, and this might be difficult, re-education and changing the culture, which obviously has to be a multifaceted type interventions with working with the journals and with the scientists, to not view significance in such an extreme and bright line way.
Yeah, thanks, Steve. It is, like Robert Rosenthal once said, surely God loves the 0.06 just as much, nearly as much as the 0.05. Psychology has adopted this among other social science fields massively, and it's used rigidly, and it's used nearly blindly, and it's used in such a silly way that even if it's so obviously not significant that in 12.5% of the papers people represent the result as being significant anyway. There is a major debate in psychology, and it's a really fresh time with the reproducibility project and many other efforts towards improvement. And it is difficult to change because the system is so focused on that, and it makes sense in a way that peer reviewers would love it, because it makes for a very easy reviewing. It's a dichotomous decision, and for researchers themselves it's easy. You can say, yes, there is an effect or not, and actually among this data, they happily accept the null hypothesis for any non-significant outcome, despite the fact that the power there should be very low, as always. So maybe one reason why psychologists are so fond of this is that they do not really have specific hypotheses. They don't have clear doses to administer, so that steers you away from effect size and estimating effect sizes. There's not a lot of formal models, although when you see formal modeling, you can use models and then test the models in a much more rigorous way. Now, but it's a problem of over the years that you do not have good theory building if the empirical bar lies nearly almost flat on the ground. Any hypothesis can pass it. So you need to have a theoretical development, you need to have researchers changing that, and in the end, as you mentioned, you need to have journal editors, like the one at Basic and Applied Social Psychology, who says we're going to ban p-values altogether and see where it goes. And he's done that now, 8-10 months ago, I think, and they're still going strong. I have to look at the papers that are published there. I've reviewed one recently, which went well, which led to an interesting discussion, and a much more scientific one, in my view, in which the authors accepted the fact that you can look at the data in many different ways, and that there's much more to learn with data than a simple p-value.
Dan?
Okay, I also had a question for Jelte, but I'll try to keep it very brief. Because I was pleased to see that you showed the stats check result and this data on errors over time, because this is one of the lines of evidence I was mentioning before that suggests that about this idea that the pressures to publish are making science worse. There is probably some truth still in it, but the whole story, the way it's framed at the moment, is probably partially incomplete or inaccurate. Having said that, I was not a little surprised by the second datum that you showed, which that goes against several independent studies that showed that the ratio of p-values nonetheless is turning towards more and more statistical significance. There are at least 2 independent studies, none of which was mine, by the way, that would show exactly the opposite trend. So all I'm wondering about that particular datum is, that's the proportion of non-significant results as opposed to what? As opposed to all the literature?
Among all results in an article.
All the results, well, but there you go, right,
yeah.
but there you go. Had it been compared to statistical significant results, it would have shown the dramatic and worrying trend towards more bias.
Depends. So this is of all reported results, those that are non-significant. So it might also be the case that they now tend to report those in more detail. That they used to just say, yeah, well, hey, all the other results are non-significant without specifying them. So it's not, in that sense, it's not a very strong way. Shouldn't overgeneralize that. Yeah.
Let's go on the other side.
All right. Again, this may be more a comment than a question, but you mentioned the John paper on questionable research practices. And what I liked about the paper was that they compared the use of questionable research practices to doping in sports. And I think we have very much the same problem that you have in highly competitive professional sports, where winning the gold medal will get you contracts and money and fame. And not getting a medal gets you nothing, and you work very hard for nothing, basically. And that's the way we have our granting system, where 10% get $1 million rewards and the others get nothing. And we have a highly competitive system where there's 10 PhD students for one tenure-track job. And in a world like that, it's not surprising that people are not following the values, but following in the end the pressures of the system. And what did they do in sports, or trying to do, to combat doping? They're making doping tests, and they're testing people for the use of doping. And I think the stats check, but other initiatives, like of course my own, are attempts to create a doping check so that we can actually have real competition for real quality to see who the best athletes are. And then I don't think it's a problem that in the end some people who got the science paper honestly get the bigger rewards and so on, because in the end, it is a competitive system we're working in, and we enjoy competing also, some of us at least, right? The problem is, just like as Lance Armstrong noticed, he was the best biker. When everybody's doping, if you want to be on the podium, you have to dope. So we have to get doping out of the system. And I don't know, is there a question here? Maybe you agree or disagree, something like that.
It sounds more like a comment, but I think it's a very valid comment. The question in the analogy is whether in research and in science we have really very good doping tests based on what information is available currently. So, Jelte can pick these probably tips of the iceberg of some malpractice, statistical malpractice, but I think that the vast majority of the machinery of the sausage making is not really very visible unless you really bypass that threshold. Let's go on the other side again.
Yeah. Steve asked the question I was first going to ask. I should have pre-registered it, but he got to, but I do want to just mention, some people are probably familiar with this, but in physics, a lot of areas of physics, they blind the data before they analyze them. They perturb the data with noise or with bias, or they scramble labels so that when they are analyzing the data, it's tricky because you have to do it in a way that preserves statistical features you need to make corrections in the data, but all these sort of decisions you're making analytically about what tests to do, what cases to throw out, they don't know if it's going to help their hypothesis or not. And I think pre-registration solves a lot of the same problems, but because there are always analyses people can't anticipate, this kind of blind data analysis is another alternative. I have a paper in Nature, thanks to some people here in the room, I had a paper in Nature with a physicist, Saul Perlmutter, on this last month, and I think there are a lot of things that the medical sciences and behavioral sciences could take a look at in terms of that.
Yes, I've seen that paper, I was very impressed by it. It might certainly, I'm pretty sure it would help alongside pre-registration. There are some disadvantages to pre-registration because you typically cannot anticipate all the choices that you need to make with to distribution of the data, outliers, weird patterns, psychometric choices in psychology, but other choices in other fields. And this might help because you can then, even if it's a simple experiment, somehow blind the code for treatment versus control condition, and then fool around with the data just as long as you want, clean it and make it as powerful as it can, and then then unblind it later so that it's the clean result, and that all decisions cannot possibly, if you do it honestly, obviously, be driven by any expectations. I really like that idea. And I would also be interested to learn, but I'll talk to you later about that, hopefully, how they implement that within the physics community, because it appears to be a standard procedure. So,
Malcolm.
So I agree that you can't determine in advance of an experiment everything that you're going to do and every outcome you're going to measure, but you should assert what you plan to do. And then when you do something different, the reader can work out why you did something different, and if it's because the data looked a bit more interesting, then they'll find you out. So there's a lot of pushback from the animal research community that we can't have protocols for animal research because experiments only last for 6 weeks and you'll lose a lot of discovery science. Well, discovery science is non-hypothesis driven research that shouldn't have any statistical tests in it anyway, because these are called hypothesis testing statistical tests for a reason, that they test hypotheses. So have a protocol if you're going to use statistical tests, and if you end up using a different outcome measure because the machine got broke or for whatever reason, explain it, and then people can make a judgment.
A question for David Moore, David Henry, University of Toronto. David, it's about rewarding peer review. I think like many people here, I've reviewed papers. I've been doing it for 30 years. I was never trained. I don't get feedback. I have no idea whether I'm any good. My heads of department apparently don't care. When I was head of department, I didn't care. I didn't ask the staff that worked there if they were doing it, if they were any good. We never sought any training. So everything you say is correct. The question is how to change that. In the discussions that you've started to have with deans, VPs of research, heads of department, do you sense there's a receptivity to really reward this properly? What's the response like, and what practical suggestions have you got?
Well, I think off the record, they're extremely enthusiastic. On the record, of course, they're stuck in Frank's machine. And I think what we need to do is come together. We need some we activity to see actually how can we deconstruct that wheel and rethink it, repopulate it with incentives and rewards that we've spoken about here. The notion of reproducibility, the notion of sharing data, the notion of actually peer reviewing. And then we may want to think about, okay, those are incentives and rewards that we may want to think about, well, what sort of currency should we put on some of those? And I think we tend to think about incentives and rewards in a quite of a linear manner, so that an assistant professor will have the same sort of model or wheel as the person in the full professor. And that seems to me intuitively quite ridiculous, because there are different needs and wants at different career milestones. So I think we need to encourage deans and other stakeholders to come together and to start to talk about this, because they're very worried about sort of making their unofficial views official. And then I think we need to, I really believe we need to experiment. So, I think Philippe Bravo and others have really talked about the notion to experiment with whatever we come up with. And I think we will find some early adopters who are willing to maybe not tear down the current system, but experiment with a modified incentive reward compared to the current. And we could see, actually, does that improve data sharing? Does it improve the abilities to replicate, et cetera, et cetera?
We can change sides again.
Hi, Veronique Kiermer, Plus. I'd like to offer a suggestion, pick up a little bit on what Malcolm was just talking about, and have the reactions of the panel to this. Is there any value in we as a community trying to define more forcefully and more systematically the difference between exploratory research and confirmatory or validation of experiments? Because to some extent, we've been talking about registered reports, we've been talking about reporting guidelines, and I think that to some extent we're trying to pack too much into one paper. And there are a lot of papers at the moment in the literature which start as exploratory research and then end up forced into a demonstration of an effect. Is a two-step process, perhaps within a paper, easier? Because in fairness, applying things like the consort guidelines works very well on clinical trials because they're very structured, there is harmony in how this is done. In an exploratory research where you go from biochemistry to demonstration of mechanism to an animal experiment in figure 6 of the paper where you have 3 poor mice and it's underpowered, it's a very different situation.
Yeah, I think it is difficult. The trouble is that, and I speak as a one-time animal researcher myself, often you don't know whether you're doing an exploratory or a hypothesis testing experiment until you've got your data. And if P's less than 0.05, it was clearly hypothesis testing. And if it's not, it goes into your next grant application. And seriously, that's what, so I reviewed a paper recently, and the suggestion from the other reviewer was that their data didn't, in fact, confirm their hypothesis. And the revision came in saying the reviewer is completely correct, so we've changed our hypothesis. And you understand nothing about it. It's certainly not the only thing that in vivo life scientists need educated about, but it's a very important thing. And the reason I think is that there's very little space for non-hypothesis testing research. Here's an interesting finding. What might this mean? The flip side of all of that is the experiment that you used to publish when you were in your previous job that would have 9 different independent tests of a hypothesis. And each of those individual experiments would be powered at about 50% if you were lucky. And every single one of them gets under 0.05. Now, the chances of that actually happening, even if the hypothesis is correct, is about 1 in 50. So we also, I think, need to be more sophisticated in the statistical testing we require of those kind of blockbuster nature sciencey papers where there are a number of independent tests of the same hypothesis that we don't allow reviewers to require that every test gets under 0.05, because that's unfeasible, actually. What it means is that people are doing 20 things and reporting the 6 that fit, and it distorts the record.
Yeah, I completely agree with this. We should be much more open to what we tended to call no results. In the days that we blindly followed Fisher, who did say that he was happy to ignore all results that were non-significant. But this is a very big problem. So we should have journals being more open to these type of results, and you can combine them in a meta-analysis and have a better estimate of the effect with much more power, etc., etc. And it's very crucial to get it into the heads of researchers that there is this thing called exploratory research. That should be valued, that's interesting, but it's exploratory, and I agree, you shouldn't do any p-values there except for some sort of test to make sure that you have some signal, but that's about it.
Peter.
Yeah, it was in psychology that we first learned about these misleading p-values in Sterling's paper from 1959. And I have always been fascinated why psychologists are so obsessed with statistics and p-values. I was once visited by a psychologist who had made a fascinating program in Excel, where he showed that p-values are very unstable. Mm-hmm. He changed small things, and they kept changing all the time, so you got almost dizzy at looking at all these changing p-values, but you could see how little it took to change a p-value from 3% to 20%. Mm-hmm. It takes surprisingly little another distribution of the data, and then you get a completely different result. So in reality, the psychologists are using an instrument they were never taught to use because they don't know how unstable it is. That's my first comment. The other comment is I've also been fascinated, but not in the good sense, that even very simple problems in psychology are usually very often completely drowned in multivariate, complicated statistical models with unverifiable assumptions, and then you are left like, am I a believer or not a believer? It ends becoming science to me. So why did all that come into psychology? Can you explain that? And can you lead the way? Can you lead the way out of this statistical quagmire in psychology?
Yeah.
No, I'm.
Everything is working so beautifully.
Well, no, I am kind of everything. I'm a specialist in internal medicine and took an interest in statistics many years ago. You can't just put me in a box.
One great.
Anyone in defense of psychology, or?
I'm more than happy to. I can very easily defend psychology by pointing at the reproducibility project and what's happening there. I would be hard pressed to see what happens if we draw similar samples from the Lancet and Nature and the New England Journal and British Medical Journal and do the same thing. What would you guess would happen?
Yeah, actually, I can give you the answer to that. 97% of biomedical papers across all PubMed that use p-values have significant results. So it's probably a bit worse than psychology in that regard.
Yeah, it would be interesting to replicate those massively and see what happens. Yeah.
So I'm a social psychologist and agree with the over-reliance on p-values. I think one of the reasons why the emphasis on p-values in psychology is the American Psychological Association actually had guidelines for 20 years. When you have manuscript submissions, you were not actually allowed to report the actual p-value. You had to only put p less than 0.05. So I think that's probably a simple explanation about why there's that evidence. You could either do p less than 0.05 or p less than 0.01. And those were the two cutoffs that were there.
Interestingly enough, it's still being used by quite a lot of research, as if they focus only on this boundary, as Fisher would have had them do, and as if they still look up the result of their test at some table on the back of their statistical book.
The same advocated publishing in other information that would be useful beyond just the p-values. Like this confidence interval. And actually psychology is doing a good job in terms of being able to really know what is going on compared to some other sciences where the exact p-values, but that's all there is.
The consort guidelines have been incredibly helpful for pushing psychology to kind of step forward. I had one other one in terms of how journals can influence the system. Annals of Internal Medicine for reviewers rates their reviewers. And you get a letter at the end of the year, and it rates you on both did you get the things in on time and the quality of your review. And that includes things like tone and sort of the substance of the review. And you get a letter, and that gets sent to you and your department chair. And it comes from the lead editor from the journal that you can then pass on. Possibly you could expand that, and you only get to report whether or not you're a reviewer for a journal if you got that designation. So that could maybe be another incentive.
Yeah, I agree. It's very important to improve those incentives. It's part of the hiddenness of that system, which is weird, because being an editor myself now and having reviewed quite a lot of papers, there's so much nice and interesting debate going on in this closed system. It's just a waste that it goes away in the Elsevier editorial system or what have you, and that people don't get rewarded for that. Publish them alongside, why not?
Sorry, I was just going to say, I think that initiatives like what you describe in the annals are very important. They'll have more impact if deans of medical schools actually more seriously reward those efforts and more seriously reward actually training their faculty members in peer review and really promoting that activity. So those letters, they get drowned out by a lot of other unfortunate rewards.
David Schreiger, UCLA Emergency Medicine. Following on with that comment, David, as I hear many of the excellent talks today, I'm concerned that this notion that it's just a matter of education, if we just educate people and change the incentive slightly, we'll fix all of this. But if we ask, why are things the way that they are? I don't think it's purely that we're just ignorant. I think that we have a system. Imagine that we clean the whole thing up. And now there are very few studies which are definitively positive. The funding agencies are embarrassed. They're funding all of this work which doesn't produce results. No one gets promoted because they haven't discovered anything of importance. The current existing structures, to some extent, perpetuating the status quo is in their interest. And you referred to Gramsci, Malcolm. One of his major concepts was a concept of hegemony. How do the people in power create a social structure which perpetuates the status quo? And I think we're living in one. If we're going to have any impact here, I think we need to get beyond arguing about how many p-values one should have or whether p-values are good or bad, and really think about how do we affect the actual institutions that are in power, because they are setting the conditions that permit this bad practice to perpetuate.
Yeah, I think you're absolutely right. One of the talks earlier on drew some solace from the fact that the number of citations matched the scores given to NIH grants. And what that tells you is that the same people citing the papers are scoring the grants, are peer reviewing everything, and we don't know if they're truly positive or falsely, but at least we know they're consistent, and whether they're consistently right or consistently wrong, we simply don't know. And we may be in a local minima where everything seems to work and we all know the rules and we know what we're doing, but we're just miles away from where actually we should be. So we need a good lot of disruptive innovation, like Enki, like lots of other things that just stir things up a little bit and see where things land. And that's all coming anyway, because publishing in the traditional sense is falling apart because open access publishing is so easy now and people put their stuff on the web. We've got a systematic review of animal models of Alzheimer's disease. We've been trying to get past Alzheimer's disease experts for 3 years. So we've given up. We've put in the database on Figshare, and anyone can use it, and we'll get our paper out eventually. But in the meantime, and more scientists will do that because they just get sick and tired of chasing the impact factor and chasing the journals. So what, disruptive innovation, when we want it now.
If I may add to that, what Brian talked about this morning was that the normative structure of science, scientists do want to do good. Youngsters can help, but anyone can help by just changing their ways. So if I go back to Randy's question about Stapel, was the dean of our faculty being found to have fabricated data in 55 or more articles. So what happened after that in the social psych group that he headed also was that the young researchers just decided that they would want to do it more openly. And we came from a field, which my own work showed that 74% of the researchers didn't share data, and they just put their data online way before even submitting their work. And what they did basically was showing what the norm of good science is, and then the new head of the department had to explain himself why he didn't do that. So you can, that's the type of revolution that anyone, if you have a critical mass of youngsters, can enforce. So.
Hi, Maya Peterson, Berkeley Biostatistics. So that betrays my bias a bit, perhaps, but I think there's a bit of bias against complicated or fancy statistics. On the one hand, that's very understandable. So you think, we've done a whole bunch of complicated things to our data. So either that means there was a lot of space to try all these complicated things and then choose the sophisticated analytic approaches that gave the result we wanted, or we tried to write them down ahead of time, but as we said, there were way too many things in our data that we couldn't anticipate, and so we just couldn't do it. And so then we were, even if we do it transparently, forced to change some of those decisions after the fact. And I just wanted to make the point that simple statistics are not necessarily the answer either. Often we really need sophisticated analytic techniques to get the best answers from our data, and that's our responsibility as researchers as well. And just to point people towards a whole area of statistics that's really works on setting up flexible analytic strategies that are flexible in a pre-specified way so that you can still use them to get meaningful inference. You can still write them down ahead of time. They can exist on your computer as an algorithm, but they look at the data in a supervised way when you actually get to the analysis. And I think that's one way forward in this area we haven't talked a lot about today.
I think that's a nice comment, and I would probably add to that the response to flawed use of statistics is probably not less statistics, it's probably more statistics and better statistics. And same thing with any index. Citations, the response is not eliminate any quantitative component, but make it better, understand the assumptions, make it more rigorous. So I think I'm talking to an audience that has lots of quantitative people on board, so probably that would be widely understood. Yes, Andrew.
Andrew Ballas, Augusta University, Georgia. I think that as we look at the imperfection of the various measures like impact factor or p-values and so forth, it should really force us to look into the long-term mission of science. So what are the ultimate goals, and what would we like to achieve? And then these measures will appear valuable, but they are only about a part of the process. And obviously, in life sciences, we think about public health improvement. That would be one of the primary goals, perhaps economic development, and perhaps some scientific models that can be used by future generation of scientists. But that might be a point that when we can look into the benefits of the non-repeatable research, and there is no better country to discuss non-repeatable research than the United States, because this country was based on non-repeatable research by Christopher Columbus, who calculated the size of the Earth, and it was a wrong calculation, and the reviewers realized it, but the Queen still funded the project, and now we have a country. So this is really a story that is not entirely kind of non-repeated on its own, because there were some other examples, and I can give you a more recent one, the Joe de Camel study that was published in JAMA. And it was an okay study, never repeated by anyone, but it really generated a huge national discussion, and the tobacco companies were forced to move out of advertising that targets children. So I think it is a more complex question than just looking at impact factor and p-values when we look at the practical impact of science. So at some point we need to ask the questions that how our methodology is actually relevant to those goals that we would like to achieve ultimately.
I think that's a very valid comment, and I think that in the breakout sessions, I would like people to think about what is it that we want to get eventually, and what type of outcomes do we want to promote, and can we measure them, or do we have to wait for 500 years to yet discover something really big that nobody had a clue that existed?
John, can I comment briefly on that? Apart from your assumption that what Christopher Columbus did was actually good, I mean, he could at least have discovered Canada, not America in the world. They figure that 85% of research is wasted. I've heard some really quite well thought through pushback against that says you're taking a much too narrow focus on what the benefits of research are. You know, you're employing PhDs and postdocs who buy food in their local grocery store. There are people coming out with PhDs who might not carry on in a career in science, but they go and populate our biotech industries and they provide the workforce that they require. And if we take a focus which is just, did this experiment that we funded produce some research which we know to be true, that is to miss some of the wider societal benefits of having an active research community. And I think we miss that at our peril.
But I think we need an active...
Short comment that I think that just healthcare general is a good example how healthcare itself started with very technical measures 30, 40 years ago, and today the quality measurement is more and more focused on actual outcomes that patient experience, and I think that maybe that's what we need to do. We need to see a shift towards that in evaluating science.
I think that Frank has the last comment.
I only had 10 minutes, but I spoke for 13 minutes, 42 seconds. But I have to say something that saying that we should educate the PhDs and the postdocs to do their utmost and to be honest scientists is not going to help. Because if you know how the system works, and this is Bourdieu's system for making social capital, this is a totally stratified system. So there's elites, those people are completely different there, who are judging your grants and who are getting the grants. And so if you want to change the system, you're up against the mob. And these people are the people who are the elites. And so the people who are most against this type of change are the ones who do very well now in the system. And they are the powerhouses in the system as well. So that's a real problem that we are going to face, and that every dean is facing in his own house. That he fears those mastodons that do well in this system, although he knows that a lot of people suffer. So I will Twitter now a paper by Pierre Bourdieu where this is explained. For those who want to read it, it's Sociology of Science. And then you see this is all about power struggle. And this is not an invisible hand. So if you let it go, again, there will be an elite who will take the power and who will make us do the work like people do now. So this is not a value-free system. This is totally politically structured based on power. And that makes it so very difficult to change it. Thank you very much.
Yeah, but then, yeah. I won't, yes, so it's a power structure, but I've always grown up as an academic believing in anarchy. So whenever my dean, the new dean, tells me something, I say, eh. I believe in science that it's about the ideas, it's about the methods, it's about whether the data corroborate what you feel is right. And so that's the value, the added value of meta research, is that doing meta research allows us to use those data and then throw it back at them and show that you're right and that we have to have better methods and do it better.
In the financial system, people knew for years that they were selling wrong mortgages and worthless stuff, but it was very difficult to change. There were a lot of people very, very well aware of what was going on, but it was impossible to change because of the power structure that was going and this power struggle that was going on. So dream on. This is not going to happen if the PhDs are going to speak up. They will just be kicked out of the system.
I hope not. It's yeah.
Okay.
This is a Netherlands point.
I think that that being said, the session should come to a close, and I want to thank our speakers and also thank the audience.